Hi, this is Mrs. Blake, and today we're going to talk about the last part of MOL conversions, two-step conversions. For this video, you need a scientific calculator and a periodic table. If you don't have a scientific calculator, remember you can just Google a scientific calculator, and the one on the screen will work just fine for these calculations. So, in the first video, we talked about what is a mole, and we said that 1 mole is like a dozen, except for instead of 12, it is 6.02 times 10 to the 23rd, and we call that Avogadro's number. In the second video, we took a look at converting between moles and pieces, because if 1 mole is 6.02 times 10 to the 23rd, we can figure out how many atoms or molecules or formula units exist in a chemistry problem. In the third part of the video, we took a look at converting between mass and moles. Mass is a really important tool because this is going to be what we measure in lab. But unfortunately, chemistry problems don't use mass. Chemistry problems usually use moles. In almost every chemistry problem you're going to need to do, you're going to need to be able to do a gram to mole conversion. Now, today, we're not going to take a look at mass to moles or moles to particles. We're going to take a look at both of them, because it is very common in chemistry to run into problems where you start with mass and you want to know how many little tiny pieces there are or how many particles there are. And sometimes you know how many particles there are and you want to figure out what the actual number of mass is. So let's take a look at some of these problems. And like every other chemistry problem you're ever going to do, it is really important to read the question and pay attention to the units. So how many molecules of water are found in 3.45 grams of water? In the chemistry problem, you are going to have a number and a unit, and that is always going to be your starting place. So I'm going to take this 3.45, but don't forget the grams. The grams are what give me direction in these chemistry problems, because I can't take 3.5 up here or 3.45 up here and use it anywhere. But I can certainly take grams and know that if I'm at grams, I know I'm going to be starting right here. The second thing those units allow me to do is I want to get rid of grams. And to get rid of grams, I know I can take whatever unit is here and put it down on the bottom so it can cancel out. Well, if I take a look at my little flow chart up here, if I'm starting with mass, I don't really have any options. If I'm starting with mass, my only option is to go 2 moles using my molar mass. And remember, molar mass has units of some number of grams in 1 mole. So I've got grams on the bottom. That means moles must go on top. And it's 1 mole. And this number is just going to be my molar mass. So for molar mass, I can add it up over here. I have hydrogen. I have 2 pieces of hydrogen from my periodic table that says it's 1.01. And I can use my periodic table. I've got 1 piece of oxygen. My periodic table says that it's 16.00. And I can put those numbers in my calculator, and I'm going to come up with 18.02 grams per mole. But this isn't a do I multiply or divide thing. My problem sets it up, and if I know 1 mole is on top, my 18.02 grams is going to go on the bottom. And that's the first part of my problem. And sometimes I can stop here because sometimes my problem will say how many moles. But this problem doesn't say how many moles. This problem asks me for how many molecules of H2O. So moles is just a stepping stone. It's not where I'm going to stop. I need to come all the way down here to be able to find molecules. Now remember, it's a covalent compound. That's why we call it molecules. The math isn't any different. So this time I'm going to go from moles to pieces And what am I going to use for that? Well, I'm going to use Avogadro's number. So a lot of students like to put this in their calculator, but your calculator has no problem with multiplying 5 or 6 numbers and dividing at the same time. So do not put this in your calculator at this point. Continue on. Because this time I have moles on top, and I want to get rid of moles, so I'm going to put moles on the bottom. And according to my flow chart, I'm going to go to little tiny pieces, and this time I'm going to go to molecules. A lot of times students will not write out molecules, but you will confuse yourself if you're writing out mole. So for molecule, I'm going to abbreviate molecule with an MC. That way I can tell the difference. This is going to be Avogadro's number. And Avogadro's number says that in 1 mole of anything, there are 6.02 times 10 to the 23rd. So in 1 mole, there are 6.02 times 10 to the 23rd. What that allows me to do then is that moles are going to cancel. And now I'm going to be at molecules, which is the unit I want, so now I can just calculate it out. Now this looks intimidating, but not for your calculator. Anything on top is going to be multiplied by. Anything on the bottom is going to be divided by. And it really doesn't matter the order, but when I put this in my calculator, I'm going to take 3.45. I'm going to take it times 1. And yes, I usually skip that step. I'm going to take it times 6.02. Remember to put scientific notation into your calculator. You have either an EE or an EXP button to use. Do not hit times and do not hit 10. Hit that button and then just put in the power of the 23. No equal sign yet. I'm going to hit divided by. I'm going to take 18.02. I'm going to take divided by. I'm going to take 1, and yes, I usually skip that step. And now I'm going to hit equals. And my calculator is just fine with that calculation. So all in one single step, before I hit equals, I'm going to push all those numbers in my calculator to come out with my answer. So it's 3.45 times 1 times 6.02, exponential button, EE or EXP, and just put in the power, divided by 18.02, divided by 1. And my calculator spits out, oh, long decimal number. I'm just going to keep 2 decimal places, so I'm going to say 1.15. But don't forget, you multiplied by 602 billion trillion. It's not going to be 1.5. Look at the very end of your calculator screen, and you should see a times 10 to the 23. On some calculators, it'll say E23, but it means the exact same thing. And this is going to be molecules. Problem number 2 is set up very much like problem number 1. Pause the video and see what you can do with problem number 2. So how'd you do? Pause the video again, take a look at the problem, and see how you actually did. This problem looks very much like problem number 1, and the important thing to remember when I'm looking at my answer is to make sure that I'm looking all the way to the end of my calculator. If I'm taking a look at Avogadro's number, I have multiplied by 602 billion trillion, and my answer is always going to be times 10 to usually the 20-something. Never usually more than that. Very rarely will you get more than that. 22, 23, 24, sometimes 25 or 26, but almost never do you see anything other than 20-something when you're doing your calculations. So let's take a look at the opposite direction. Because sometimes I can take a look at a problem, and I'm going to start with particles, and I'm going to need to go to mass. Now, these problems always set themselves up if you read the problem carefully. So, number 3 says you have 4.85 times 10 to the 23rd atoms of carbon. What is the mass in grams? Now, this one's worded a little bit differently, but it is the exact same type of calculation. Again, I am always going to take the number and the unit, and that becomes my starting point. So this time I have 4.85 times 10 to the 23rd, and this is atoms. And I can draw this line, and I know that if atoms is on top, atoms has to go on the bottom because I want to get rid of atoms and turn it into something else. Well, if I have atoms on the bottom, I'm not at mass, and I'm not at moles, so I must be at particles. And sure enough, if I look underneath my list, atoms just talks about an element, and since we're talking about carbon, carbon's an element, that would be why the term atom is used. Now, if I'm starting at particles, I don't have any options. If I'm starting at particles, only place I can go is to be able to go to moles. And what am I going to use to do this? Well, I'm going to use Avogadro's number. And Avogadro's number gets me 2 moles. And it says that in 1 mole of anything, there are 6.02 times 10 to the 23rd. But I don't have to worry about where my numbers go because if moles are on top, it goes with a 1. And the 6.02 times 10 to the 23rd is going to go on the bottom. And what that allows me to do then is atoms cancels out, and now I'm left with moles. But I've got to read my problem carefully because my problem is not asking me to go to moles. My problem is asking me to go to mass in grams. So moles is just kind of a stopping point. I need to go back, and I need to go now from moles to mass using my molar mass. So when I take a look, I can continue this problem on, just like the problems above. Moles are my unit now, and I don't want moles. And what am I trying to get to? Well, I'm trying to get to mass in grams. And this is going to be my molar mass, which has a unit of grams per mole. So for my molar mass in 1 mole of anything, I can use my periodic table, and since it's just carbon, carbon's going to be 12.01. And what that allows me to do is to get rid of moles because it's top and bottom, and I have grams, and that's what my question is asking. Find the mass in grams. Again, anything on top is multiplied by, and anything on the bottom is divided by. So what I'm going to punch into my calculator is going to be 4.85. Now I have scientific notation, so I'm either going to use my EE or my EXP button, and I'm going to put in 23. I'm going to take it times 1. I'm going to take it times the 12.01. I'm going to divide by 6.02. Again, I'm going to use EE or EXP and not try to put it in my calculator the other way. I'm going to put 23, and I'm going to divide by 1. And my calculator is going to come out with 4.85 exponential key 23 times 1 times 12.01 divided by 6.02 exponential key 23 divided by 1, and then I hit equals, and I am going to come out with, hang on, calculator error. I'm going to come out with 9.67. Oh, it's 0.675, so I'm going to say 9.68 grams. Problem number 4 looks very similar to problem number 3. So pause the video and see what you can do with problem number 4. So pause the video again and check your answer. How did you do? It's really important to remember while you don't want to do the calculation yourself as one step, your calculator has no problem. It's really important to get comfortable with doing that. So 2-step conversions, follow your units. and it'll help you figure out any time you need to do